Salam Sejahtera and good day. My name is SARAVANAN SANGAR. I am from program BMMMM and section 1/2. My supervisor name is Dr. Sitya Matana Parman. My bachelor degree project of semester 2 is stress intensity factor investigation on thin wall I-beam using finite element method. The table of content for this slide is number 1 is introduction, number 2 is for literature review, and number 3 is methodology, and the last one is the expected result. Number 1, introduction. The introduction is stress intensity factor, which is called SIF. The research background for my project is the stress intensity factor SIF plays an important role in the practical application of the principle of linear elastic fracture mechanism, which is LEFM. The stress intensity factor is very useful for assessing the security and the reliability of cracked machine and parts. This principle allows you to calculate the crack growth rate of components under the fatigue loads and stress corrosion. The stress intensity factor, which corresponds to the stress of the part and crack in the material. The number 2 is the problem statement for my project. The available method to identify the stress intensity factor on a thin-walled I-beam is a long numerical method or mathematical calculation which takes up a lot of time and energy. The second problem is the mathematical calculation might not give us the accurate reading because might make mistakes while doing the manual calculation. My research objective for my project is to calculate stress intensity factor SIF of the cracked I-beam from the finite element software result. The second objective is compare the stress intensity factor SIF graphs obtained with the one published in engineering books. The scope of the research for my project is number 1, identification and calculation of stress intensity factor values on a thin wall I-beam specimen made up of aluminium through finite element analysis method of calculation using finite element software. The second one is to study on a single edge crack through mode 1 fracture on a thin wall I-beam specimen made up of aluminium will be carried out. The last one, development of SIF graphs using finite element software to compare and analysis against the graph obtained from the ones published in engineering books. Let's see the literature review for my project. The research I took for my project in my literature review is about I-beam. The first thing I'm going to talk about is type of beams. The most beams and structures can be divided into thin wall or thick wall types. This will be separated by their web thickness or flat thickness. The equation used for the thin wall I-beam is Tmax over h less than 0.1. I mainly talked about the thin wall equation is because this project about the thin wall I-beam. The cross-section view of the I-beam will be I showed in the slide. This is the cross-section view of the I-beam. This is the height of the I-beam and the Tmax. Tmax, which is the flat thickness. Let's see about the defect of the I-beam. There are some setbacks when using a thin wall I-beam for the structure. For instance, corrosion and crack defects may occur because of the corrosive environment and high load application. These drawbacks may lead the thin wall I-beam to fail under the designated load. The next main part is crack. Crack is the common occurrence in engineering steel structure that was subjected to constant repetitive stresses. Crack is the second most frequent cause of damage to the structure after the corrosion. The stress that can cause the cracking may be above below the material. This is the example of the crack on the I-beam, which is thin wall I-beam. Stress intensity factor. This also have the main role in my project. This is the stress intensity graph which I'm gonna do for my project. This is the graph I took from the article and I'm gonna compare with my project. The first graph is about the stress intensity factor against normalized crack length graph, axial tension force. The second graph is about the stress intensity factor against normalized crack length graph, but this is the bending moment graph. The second one, there are three types of mode of fracture in the stress intensity factor, which is opening mode, sliding mode, and tearing mode. These are the example of the mode of fracture. But I'm gonna do my project with the opening mode fracture. The next main thing I'm gonna talk in my literature review is software. The software used for this project was finite element software. The basis of finite element analysis software program is shaped with the aid of using the legal guidelines of physics expressed in mathematical fashions. The usage of FEA software program is extended from large organization and establishment that guide teaching engineers to smaller organizations in lots of exceptional industries and established with the extensive type of disciplines. This is the geometry of I-beam. Let's go to the methodology. This is the flowchart of my project. Let's see about the phase 1. In phase 1, the research started with understanding the research background and identifying the problem that is being discussed in this research. By identifying the problem statements, the next objectives of this research are obtained. Next, to improve the knowledge regarding about this research, the literature review is done to develop a better understanding about estimation of stress intensity factor on a aluminum I-beam specimen with different sizes of crack. This study uses finite element analysis as the solution to the current problem regarding the stress intensity factor estimation. So it is important to know the theory of stress intensity factor, the formula of stress intensity factor, K. The K is the symbol for the stress intensity factor, and the way to identify the K value using the finite element software and obtain graphs for different size of crack subject to bending and axial tension force. Let's see the phase 2. In phase 2, a specimen is selected which is I-beam specimen and the specimen is made up of aluminium. Therefore, the specimen has its own characteristic which will affect the stress intensity factor calculation later. After selecting the specimen, calculation on the I-beam specimen will be done subject to its dimension prior to the stress intensity factor calculation. The specimen will have different size of crack subject to bending and axial tension force on the I-beam specimen. The last part I'm going to talk is expected result. This is the reference for my project, and that's all from me. Thank you.